Now we were discussing that since this vertical scaling, right, the adding more and more hardware to the same machine or to the same server is not a probable solution or good approach if you are dealing with very fast pace data increasing, okay, in your application. Now let's discuss one, kind of architecture where we can cope up with the increasing data size, okay. And the points to understand is that basically we don't want a very high end servers, very high end thing. We don't want high reliable, because if you go for very high reliable hardware, basically they are very costly. Okay, what about commodity hardware? Okay, so when I say commodity hardware, let's when I say commodity hardware, what are those? So commodity hardware is something like which is available at very cheap rate, or it's like it's being manufactured at very large scale and you can easily get it in the market on very cheaper price if you compare it to any reliable system, right? So just like our laptop, right? So we buy our laptops within like 40,000 or something like that, and then basically again there is no guarantee. I mean, today your laptop is working, tomorrow it will be working or not. I mean, maybe your hard disk crashes or motherboard may go off or screen will go off, right? And then again, if you have a warranty or guarantee, basically you can just replace under it, so it means that these are like kind of commodity hardware which is like being manufactured at a very large scale, right? If you talk about any laptop, you will find it like i5 processor and 8 GB RAM, and then some these are like very cheaply available in the market. You can find a lot of options, you can find a lot of places where you can easily buy it out. Okay, these are all called commodity hardware. So when you talk about commodity hardware, we want a certain system that will be the solution if you compare it with the vertical scaling. Okay, so let's take an example, and then through that example we will understand that what could be the possible solution in order to store more and more data. Okay, and then you can just keep grow this architecture, and then that's it. I mean, just keep growing the architecture will help you to store more and more data on it. So let me take an example of data, and let's say I will say there is one file, let's say file.txt, okay, and its size is 1 TB, and I want to store it. So what I will do is I will pick a laptop. Okay, this is laptop one, I will say, and let's say the laptop one, it is having almost 1 TB of hard disk, and let's say i5 processor and around 8 GB of RAM. Because I'm not much concerned about i5 and 8 GB. Currently we are not thinking in the time in terms of processing it. First thing that we are dealing with is how to store this data. So okay, 1 TB, I can store that 1 TB over here. So let it store here. Okay, so what will happen is the data is stored. Now we already know that this laptop is a kind of commodity hardware. I mean, it can go off anytime. So in order to not lose the data completely, what we can have is we can have one more laptop in parallel to it, and I will say laptop 2. It is also having a similar 1 TB of hard disk, i5 processor plus 8 GB of RAM. Okay, and you will store same copy or identical copy of that 1 TB data over here as well. Okay, so this is 1 TB data here, this is 1 TB data here, and you can have like kind of connection in between them. Okay, but still now we reduce the chances of total data loss to 50%. Okay, what's if I want it to reduce further? Okay, I don't, because it may happen that since again it is a commodity hardware, though it is 50% chances only, but 50% is also a very big number. So I will have one more laptop with a similar similar hard disk plus i5 processor and 8 GB of RAM, and I store one more copy over here. Now I reduce the chances of total data loss to 33%, and now we are good. Okay, we spend some money on this laptop, but again it is a commodity hardware. It's cheaper than if you go for very reliable server. Okay, and now this 1 TB will come here. Okay, so I'm just trying to tell you the approach. Okay, though in basically big data and Hadoop, where we now which we will talk later, This is not the exactly machines used basically. Again, even if, because the thing, if you are if you are doing business and the data is very critical to you, you are not going for commodity hardware. Most of the servers, they are definitely very reliable servers. Okay, but Hadoop or big data, when we talk about it, they are made for failure. That's what actually how they advertises, they advertise themselves. Okay, they are built for failure. Okay, so we'll talk more on that later, but let's discuss on this particular how we can add more and more number of machines and keep our data growth in, we can handle more and more data that will come to get stored. So now we are using three laptops to handle this 1 terabyte of data in a fault tolerant way. Basically, if one laptop goes off due to some reason, we still have two laptops with the available data in it, right? And then we will get enough time in order to replace the laptop one if it go crash, and then again store the data back into it in order to have this kind of three copies of this 1 terabyte. Okay, so this three copies is basically sometimes also called replication factor. When I talk about RF, it is called replication factor. We will use it later, but this is very, very simple term. And most of the times it is three. It means that every data that you do have on your in your architecture, it is having three identical copies is stored in different machines, so that even if one machine goes off, you still have two more copies identically available on different machines from where you can go and read or work with. What about if this data goes to 2 terabyte? Now I do have one more terabyte to be stored. So let me change the color. So I will say this 1 TB is coming. One more. So what I will do is I will add up three more laptops with the same configuration, and I am good with that. Okay, so this is now becomes your laptop 3, this is become laptop 4, and this is become laptop 5. Sorry, 3 4 5 1 2 3 sorry 4 5 6. 4 5 and 6, and again 1 TB plus i5 plus 8 GB. Here also 1 TB plus i5 plus 8 GB, and 1 TB plus i5 plus 8 GB, right? And the second 1 terabyte data, okay, that gets included, so I am going to store it over here in 3 copies. Okay, now what about if you get more and more data? You just keep adding, okay, and there is no limit on it. So basically, this is what is called horizontal scaling, where you are not adding the hardware to the same machine, you are adding machine itself in the architecture, and this is what is called horizontal scaling. Okay, and most of the solutions that you will see in the big data or Hadoop, mostly they will advertise themselves as to be a scalable system. And whenever you hear this term called a scalable system, it always means it is a horizontally scalable architecture. It means that if your data size grows, you keep adding more and more machines to the existing architecture, and you are good. You are good with the increasing data capacity. Okay, so this is what is called horizontal scaling, and this is the approach that most of the big data, solutions will provide you. No matter it is Hadoop or Sparrow, you can go on anyone, and then definitely you will get this kind of scalable solution. Okay, so this is what is called horizontal scaling, and this is a fault tolerant way of storing the data. In terms fault tolerant, why I am saying fault tolerant, because even if one machine fails, you still have the data available on other machines from where you can serve the user request or you can read the data from, and then you will get also enough time to replace the faulty hardware or faulty machines with some good machines. Okay, now this is clear. I will show you some very some website basically, or some companies who are handling the data in really very big size, and it is very difficult for us to understand that how they are actually handling it, right? So and then this, let's go through this slide. Basically it says that Facebook generates 500 terabyte of data every day. So 500 terabyte, it's like 2 years before, I think, and like nowadays it should go more than 1000 terabyte per day. Now if you see that what is 1000 terabyte, it's two huge data set, right? I mean, we cannot think of handling it on a very single machine or single server, definitely. So 1000 terabyte of data daily generation, because we keep posting a lot of videos, uh, photos, pictures. Okay, there are a lot of text also get generated on Facebook. Okay, and all that will be stored on there, some data centers of Facebook's across the globe. So this is one of the very heavy data set, you can say, daily, that they are handling. Okay, Facebook is basically, when he Facebook sees the problem, it may be the first time that anybody sees in the world, basically, because the size of data that they are handling, it's so huge that they started facing problem of either how to store it, and they had to design the solution, because whatever problems they are facing, basically there should not be, or there might not be any pre-existing solution or pre-existing product that will help them to, in order to solve that kind of problem that they are handling. So they have to be very innovative. Okay, and that's how the innovation will come, basically, because the problem, if you are the only one who is facing it for the first time, then you have to design a solution. You cannot rely, because there is no existing solution that anyone can provide you to deal with that particular problem, right? So you will come to know that, basically, while we will go further with our Hadoop tutorial, you will see that one of the component called Hive, that is completely designed by Facebook only, because they had faced problems, and nobody was there in order to give them the solution. So they had to be innovative and then come up with this kind of brilliant solution. Okay, and you will see that the Google and the other websites who are dealing with this kind of problems, basically they are getting more and more innovative in order to solve come up with very, very smart solutions. So Facebook is having some of the largest clusters of Hadoop that will handle, that may go up to around 8,000 or 10,000 of machines. Okay, the 10,000 of machines interconnected in order to form a cluster. So basically, when you talk about this kind of horizontal scale, each one of these laptops are said to be a node. Okay, and this group of nodes, or this group of laptops, are said to be a cluster. So if I just encompass them in a very big circle, so basically this red circle is said to be a cluster, and each of these nodes are said to be, I will say, node 1, this is node 2, this is node 3, this is node 4, node 5, and node 6. Okay, and the number of nodes in any cluster can be increased, okay, to some very large extent, in order to cope up with handling more and more data. Okay, so scalable solution is something that will also provide you the very easy way of adding more and more machines, or if you don't want, you can also remove it from them, right? So suppose if you delete 1 terabyte data and you don't require the last 3 laptops, you can easily remove them from this architecture, and that is why it is said to be scalable. And whenever you say scalable, it is always a horizontal scaling. Okay, the other example is a plain black box, and there are, like, you can just read through this slide. Basically, there are multiple examples. So plain black box is basically one of whenever you again, the color is not black, it is orange. Okay, why it is said to be black box? Because it is the internal media, that is hard disk and all. Okay, just to keep the record of the plane. Whenever plane flies, basically it keeps generating a lot of data from different sensors. So it will also be recorded as a data, and also the voice of pilot and the communication between the ATC and the pilots, and then mutual communication also getting recorded in your recorder. So basically there are two different units in black box. One is for data recorder and another is for voice recorder. So if you combine them, basically it will give you around 500 to 1 terabyte of data per 1 hour to 2 hour of flight. Okay, and this needs to be analyzed in terms of like some emergency, or some if just plane faces some emergency while during the flight, and to avoid that kind of emergency situation, what went wrong, okay, and what are all the possible policies or design or technology changes may be devised in order to make it more and more safer for the flyers or for passengers, right? So space engineering, and then again, you will have some very big site like Amazon and Flipkart again. There are a lot of sale of product. Even some banking websites or banking banks basically have are handling tons of data. Okay, in terms of, because everything is now going digital. So when you say that the 90% of data on this earth generated in last 2 years, so this is a true statement, right? So if you said there are like plenty of petabytes of data on this earth, and 90% of it is just generated in last 2 years. Okay, and this will remain true for next few more years. Okay, so the size, or the velocity, basically that's what actually we call triple V's of big data. Triple V's. So it is mostly said to be variety, velocity, and volume. Okay, variety, velocity, and volume, and it keeps increasing. There are variety of data, then the velocity is like the speed of it, and then the overall volume of the data, it keeps like this is what is called triple V's or three V's of big data. Okay, now the question comes, uh, if this is a solution, this is when we talk about this scalable solution, Hadoop actually provides it. So it is more towards horizontal scaling of the infrastructure, and it will scale itself. It will accommodate itself in order to growing size of data. So now the question comes, basically, what is big data? When this problem occur, from which point you can start talking about, okay, since then or since that point, basically the big data problem has come. So again, the big data problem is not something new, or it has not just come in recent years. It had been there. Okay, how? So basically, how do you define a big data, or how do you define a data to be a very big? Okay, so big data is what? Big data is 1 petabyte of big data, or 2 petabyte of big data, or it is like 1 terabyte is big data. No, we can say the big data is something that is that the size of data is actually more than the handling limit of your current infrastructure. So let's say 10 years back, if you had like Pentium 2 processor with like, let's say, around 10 GB of hard disk, so basically 20 GB of data would be definitely the problem of big data in that edges, where you had only 10 GB of hard disk. Okay, currently if I say my laptop is having 1 terabyte of hard disk, and around I'm not talking about CPU and cores, only terms of hard disk basically. So some 5 terabyte of data is the big data problem for me right now. Okay, if you are handling with a mobile, basically the mobile is having not more than around 16 GB or 64 GB of chip. So 128 GB of data is definitely the big data problem for you, because it had been there. It's not something new. Now the problem is, or the issue that we need to understand is basically, so Hadoop has just come in recent years. So like around 2008, it got implemented as a production, and then in 2013-14 we have got it in India as a boom, and a lot of projects from the different companies are getting they are getting in Hadoop. So what was, or what are the other technologies basically those were there prior to Hadoop in order to solve this kind of big data issues? Okay, so what I will do is, now I will name the company and then product and their product corresponding to, and we will just discuss about them, that what were they and how. And these are actually these whatever I am going to write on the screen, basically these are the product and services, basically those who have been there and still like in the market, but now they are like struggling in terms of getting more and more business. So let me name them. So I will name first, like say IBM, and its product is Netiza. Netiza. Then we do have SAP HANA, and we have Green Plum. Then we have Oracle Exadata. Then we have Teradata. Okay, so these are some well-known products, and they had been there prior to Hadoop basically, and were giving the solution of this kind of big data issues. Mostly they are data warehousing solutions. And when you talk about data warehouse, so it's like kind of when I've been talk about warehouse. So warehouse is something like a very big place where we keep a lot of stuff. Okay, and then from that particular warehouse, depending on different product demands, and we will just send a full truck basically loaded with some material, and then we will just distribute it to the retail stores, right? So warehouse is something very big. So when we talk about data warehouse, it means that a warehouse of very large amount of data. And when we talk about data warehousing solution, it means these are all the guys which have been those who have been there, like in order to provide you the solution for your data warehouses. Okay, so in data warehouse you will have like plenty of data in terms of terabytes or petabytes sometimes even, and that data is like corresponding to the last prior some few years of business that you have been doing, like 5 years or 10 years of data combinedly stored in the data warehouses in multiple tables with some kind of connections among those tables, and you will just fire a query, and it will take some large amount of time, but definitely will come up with a very uh, good overview about what business, how did you take your business decisions, and how does it affect, how did it affect your overall business growth. Okay, and then depending on that particular queries and analytics of that data that data warehousing solutions will provide you, you will again take some future decisions on your business, that how you should go, what are all the decisions you should take, so that you will get more and more either customers or increase your overall sale or profitability on your whatever you are doing. Okay, so basically that is what is data warehousing. Now all of these systems mostly are related to that only. So, and how they are like being so if you talk about the infrastructure or like architecture of this data warehouse solution, they are like kind of towers, and each tower or each server, basically tower is said to be server, and each server may have like very plenty of hard disk, plenty of RAM, plenty of number of CPU cores in order to do the analytics on the top of data that is getting stored in that. And some of like this kind of servers are interrelated in order to provide you the very solution for handling very big data. Okay, but what is the problem with that? I mean, why there was a need of Hadoop, or why Hadoop evolved? So that is what we need to think on. So the ultimate thing is the price that is related to them. Okay, uh, they are very heavily cost. I mean, they are very heavily costed to the client. I mean, they are very costly systems. They are like running in millions of dollars if you try to purchase the license of their server and then all software and then store data. And suppose if you want to grow the capacity of your data warehousing solution, again you need to purchase from them, and they will cost you heavily. Okay, so let's start with the IBM Netezza. So Netezza is basically one of the product. So Netezza was a company in 2000 that got established by one Indian American in year 2000. Okay, and he had seen some like kind of the big data problem that will definitely come in the near future, and he had devised that solution in such a way that basically it will be kind of scalable. You can add more and more number of servers or uh, uh, towers basically in order to increase the capacity of handling the data, and then on the top of it also it will provide you the analytics. The word Netezza is basically Urdu word called Natiza. It means that the result. Okay, so result means that though it is pronounced as a Netezza because it's like in American accent basically, since the company got established in California and in Silicon Valley, and basically then what happens is why it is said to be IBM Netezza, though it was a company itself as Netezza that in year 2000 it got formed. In year 2010, IBM did not have any solution for providing any data warehousing. Okay, though the IBM had some kind of like, tools like for doing ETL, like data stage, quality stage. Okay, that kind of tools that IBM had is still having, and that is more towards the ETL kind of thing. We will learn ETL later. I'm just trying to tell you that there were solutions from the IBM for ETL. So IBM did not have any complete data warehousing solution on its own. So what IBM did is like he IBM came to know very late that okay, some big data problem will definitely come in future, and he did not have any product at that time in order to cope up with that, right, or sell something for that. So he bought the Netis as a company. But by that time, Hadoop evolved, right? So in year 2008, Hadoop came, and it started growing because since Hadoop is open source, and open source, I will explain you open source now after this. So since it's open source, it gets evolved very fastly and came up in the market and getting used. Since it is free, open source is always mostly free. So since it is free solution, most of the clients and most of the data warehousing solution finder or seekers basically moved to the Hadoop. So IBM did not even have very good business with Netisa, and most of the Netisa projects might be either closed or being migrated to Hadoop. Okay, so it's like very they faced very great loss in that. Now second comes to SAP HANA. SAP is like again a company in HANA is their product, which is basically a kind of in-memory database. Okay, so it can handle around 4 terabyte of data directly in memory. Okay, and you can imagine that if the data directly in the memory, how fast it will be. I mean, you are querying the data and it will be like milliseconds latency, you will get the results back. Okay, and that too on 4 terabyte of data. But again, since it is having a very large RAM of thing, it is very costly. Heaviest, though it is fastest you can say fastest system on the earth, because the whole database is stored in memory only. Okay, there is no hard disk at all associated. So third comes Greenplum. Again, Greenplum is similar kind of Greenplum and this Oracle Exadata. They are again the similar kind of data warehousing solutions provider. Fifth one is like Teradata. So Teradata itself is a company, and now they had been advertising themselves to be data warehousing solution provider. Now they are advertising themselves to be the big data solution provider kind of thing. So Teradata in 1984 had created one server that could handle 1 terabyte of data that time. So 1984, 1 terabyte is too huge data set to handle during that time, right? So definitely it got a popularity, and it got very good business during those times until recently when the Hadoop came in market. Now they are completely focusing on big data. Okay, and they have modified their appliances in order to install Hadoop, and they had create some you can say alliance with Hortonworks and other Linux based platforms, so that they can design their solutions more friendly for installing Hadoop and doing some analytics on the top of it. So now this inception of Hadoop and introduction of big data and other technologies, like now changing the existing solutions in order to more divert towards the friendship with Hadoop and their big data technologies. Okay, so everybody is running behind it now. Any questions?